So the first part of this chapter, we're doing just chapter 4A. And like I said, that's only going to be on 4 lessons, okay? So the first 3 go really well together, and then that 4th one's going to be one of its own kind of thing. All right, so let's go ahead. We're going to do 4.1a today, and we're just going to do, bless you, just a little introduction into parabolas. So this chapter is going to be all about parabolas and factoring and solving and all kinds of good stuff. So, all right, little introduction. Well, what is a parabola? You saw a parabola back in chapter 2, I think. Chapter 2, yep. You saw the parent function of the parabola. And so a parabola, the formula or the basic equation is y equals ax squared plus bx plus c. Okay? It's called a quadratic function. Have you ever heard of the quadratic formula? Yeah, that's going to be later on in this chapter. These are quadratic functions. Okay? And a is not 0. If a was 0, then this would be a straight line. So it's a quadratic function. We all know that the basic shape of a parabola is, what kind of a shape is it? It's a what? It's a U. Is it a me? Is it a U? It's a U shape. You're right. Now, if I'm really full of it today. If a is greater than 0, then that means that your parabola is going to be a U shape that opens up. If a is a negative number, if it's less than 0, then your parabola is going to open down. Okay, the U shape. Now we're going to spend a lot of time doing 2 different kinds of forms of parabolas. Bless you. Remember our lines, we had 3 different forms. With parabolas, we have 2. Our first one is the one I wrote here. We're going to do that for lesson 4 too. The one that we're going to focus on today is vertex form. I like vertex form better. The other one's called standard form. I don't like standard form really. Vertex form is y equals a x minus h squared plus k. And if you remember our parent function and shifting and stuff, then this should look very familiar to you. Okay? All right, so some things about vertex form and the vertex of this parabola. So the vertex is going to be at the point hk. Remember, we move the opposite direction on the inside and then the same direction up and down on the outside. A parabola is symmetric, okay? If you draw an imaginary line down through the vertex, that is called the, does anyone know what that's called? The axis of symmetry, yeah. The axis of symmetry. Now that's a lot of words to write for me because, you know, I like symbols and math and stuff. I usually just abbreviate it as AOS. The axis of symmetry is always going to be a vertical line because these parabolas are opening up and down. They're functions. They're quadratic functions. So it's going to be x equals, and it's going to be whatever number the vertex has for the x. So it's going to be x equals h. So if the vertex is the point 3, 2, the axis of symmetry is x equals 3. Okay? All right. What else? What else? We know that, I'm kind of running out of room, are you? You're probably not. I gave you a lot of room. We know that the parent function, you can just keep writing this below. The parent function of our parabola is y equals x squared. Okay? We know that that parabola right there has a vertex at the origin, 0, 0. And it's just up 1 and over 1 in each direction, but it's not linear. Okay? It's not like a V shape, like a what's that called? Absolute value. It's a curvy U shape. There we go. And that's what it looks like. Okay? Now, for a parabola, we are going to discuss 2 things. We're going to discuss the domain and the range. Now, we've done domain and range before, but it was like easier stuff. Like it was points. And so we knew the domain were only going to be the x numbers that are being used in our graph, and the range were the y numbers. So if you look at the domain and range of the parent function, you will see that, see this graph, it keeps going in both directions. So when you're looking at the domain, you're looking at all the x values that are being used. And so every single x value is on this parabola because it keeps going out forever. And so we say that the domain of this parabola is all real numbers. That's a capital R. I know it looks kind of weird. It's like a bold R. Like it's like 2 lines and then like that. Almost looks like a P and an R put together or something. I don't know, but that's the symbol for all real numbers, okay? And then the range is going to be all the y values that are being used. Now the y is up and down. For this graph, the parent function, are there any of these y's on the parent function? No. What's the smallest y value? 0. And then it's everything above that. So the range would be all the y's that are greater than or equal to 0. There you go. So the domain will be exactly the same every single time for every single parabola. If you get the domain wrong, I cry a little bit onto your paper. So if you get your paper back, it's wet. Yeah, it's the tears of your teacher because you didn't get that right. But the range is the hard part. The range will change every time. Okay? All right. Ooh, look at, we've only learned that much stuff. That's pretty good. Okay, let's go ahead now and let's do some graphs. So we're going to make a table of values and graph the parabola. So here we go. Go ahead and give yourself a little XY chart here. By the way, if you ever have to graph and you're not sure what it looks like or what it's going to be, just pick some numbers for X and plug them in and just do it old school. Okay? All right, so let's go ahead and pick some numbers for X. I always like to start by picking the number 0 because it's the easiest thing to do, right? We pick 0, we plug it in, we get 1/2 times 0 squared is 0. And we kind of should know that because is this shifted left or right at all or up and down? No, it's not shifted at all. So 0, 0 is our vertex. Let's go ahead and pick 1 now. 1 seems like a reasonable number. So we're going to square 1, multiply it by 1/2, and we get 1/2. It's kind of an ugly number, right? So 1/1/2 is right there about. And then let's pick -1. Let's go on the opposite side. And when we take -1 and we square it, we still get +1 times 1/2, which is 1/2. And that's where we get that symmetric look going. All right, let's pick 2 now. Don't forget to square the 2 first. Okay, when you plug this in, you square the 2 first. 2 squared is 4. 1/2 of 4 is 2. We get the point 2, 2. And do you see how it's going to curve there? It's not linear. And then let's pick -2. And when you do 1/2 times -2 squared, you square the -2, which is 4, times 1/2 gives me 2 also. So that would be 2, 2 right there. All right, now we're ready to graph. And so it's going to look like this. Ooh, that's a pretty good one. Now for me, I require 3 points. I want to see, I put 5 on here, 1, 2, 3, 4, 5, but I need 3 points in order to draw a parabola. I need the vertex and then 2 other points, okay? Now, if you know that there's an axis of symmetry here, which we do know, we can always take this point and reflect it over to the other side and get another point, okay? So those are always ways to do it. Pretty good? Now here's the thing. Notice something. Do you see this 1/2 right here? You cannot think of that as slope. You cannot think that this is up 1 and over 2. That's not true, okay? If you did think of it as slope, you could think of it as up 1/2 and over 1. Up 1/2 is right here, and over 1, see, that was those points that we graphed. But you cannot do like regular slope like up 1 over 2. You can't do that, okay? All right, let's go to number 2 now. Or, sorry, number 1B. Okay, so the next one, it's going to be a lot like the last one. It's not shifted at all, but this one has a negative out front, so we know that this parabola is going to open what? Down. Exactly. Good job. Who said that? Good job. Okay, go ahead and let's start with 0. 0 is always my favorite number to plug in. 0 squared is 0 times -3 is 0. So we know the origin is our vertex. We graph it. All right, let's pick 1. 1's a good number. 1 squared is 1 times -3 is -3. And then I like to pick the opposite of -1. -1 squared is +1 times -3 is -3. And like I said before, so 1, 1, 2, 3. If you want to, you can remember that there is a, axis of symmetry through the vertex. And so you could just reflect your point over to the other side if you wanted to do it that way. Now, because this is -3, it's not a fraction, we could have gone 1, 2, 3, and over 1. It works. It works when that number is an integer, okay? It didn't work over here as a fraction. You can't do up 1 and over 2. but you can when it's like -3 or +2 or +4, anything like that, okay? All right, so let's graph it. 3 points is all that I need. And I'm going to graph my parabola. And do you see how like skinny it is now? That 3 really stretches it out. Because what happens is my normal one would have looked like something like that. That's my parent function. But that 3 makes it super skinny. The 1/2 makes it fatter. Sorry, I called that parabola fat. All right, next one. Here we go. Next page. Backside. All right, now we're going to graph by shifting. Now this should not be scary to you. It shouldn't be weird. It should be exactly what you did back in chapter 2. It's kind of like a refresher, okay? If we have y = x squared plus k, then that means I'm going to shift my graph up. If I have y = x squared minus k, I'm going to shift my graph down, okay? So if you want to write that down, you can. If you remember it, great. Good job. So we're going to start with our parent function. Now, you do not have to graph the parent function. Okay, you can picture it though. Can you picture the parent function just sitting there? Yeah. And we're going to shift this thing down 5. We go 1, 2, 3, 4, 5. That's our new vertex. So our vertex was at 0, 0. Now it's down at 5. And this is simple up 1 over 1. And there's the graph of it. Okay? Basic parabola shape. Make sure you round it. Make sure it looks better than mine. Mine looks really bad. Now let's talk about domain and range on this one. Here's a chance to get every single domain right forever. Okay? Domain. What's the domain of this parabola? All real numbers. Someone in my last class, she's like 5, but she was kidding. And I was like, I just told you it's always all real numbers. She's like, I was just kidding. I'm like, oh. Okay, and then the range is whatever the smallest y value, since this is opening up, it's whatever the smallest y value and all the y's above that. Nothing down below. None of those y values are on this graph. So where does this start? -5 and goes up from there. So we can say that the range is y is greater than or equal to -5. Okay? Does that make sense? Yeah? Pretty good? All right, let's do B now. B, don't forget, when you have y = x minus h squared, that means that you're going to shift to the right. Opposite direction of the inside stuff. And y = x plus h squared, we're going to go Beyonce, right? To the left, to the left, to the left. Sorry. And you guys are quiet today. My jokes are bad, though. You're tired? Yeah, me too. Same. Okay, so here we go. We're going to shift 1 to the wrong. I'm all wrong. 1 to the left. There you go. And you corrected it before I could tell you were wrong. All right, so we're going to shift 1 to the left. You just go count up 1 over 1, and you draw your nice, pretty parabola there. And there it is. Okay? All right, domain and range on this one. Domain, all real numbers, every time. No matter what, okay? Until it's not. That's not until chapter 10. Don't worry about it. It's all real numbers. All real numbers, okay. And then the range, y, it's opening up, and it's what's the lowest y value that we have? 0. So y is greater than or equal to 0. Very good. All right, the next one is, it's very shifty. It's 2 shifts in 1, okay? So here we go. Start with your parent function at the origin, 0, 0. And we're going to shift this thing 2 to the right and 1 up. 2 to the right and 1 up. So you start at 0, 0 and you count 2 to the right, 1 up. That's my vertex. And I'm going to count up 1 and over 1. And I'm going to draw my parabola. There you go. Beautiful. Okay, now, without anyone saying what it is, I want you to write down on your paper what you think the domain and range is. And if you're wrong, we'll just, we'll erase it, scratch it out, whatever you want to do. I hope you're right for the domain. Of course, it's all real numbers. And who's got the range? Yeah? Yes, okay, so we have to say y is greater than or equal to 1. Perfect. So y is my lowest value. Everything above it works. Okay, last one of these. Yeah, you always have to say y, because that's the range of the y values. All right, this one's a little weird looking. I put a decimal in there, and I gave you a negative. So I did two things. But all this is going to be a shift of 1.5 up. And because that's a negative out front, our parabola is going to open down. It's very sad. So negative, like, you know, some of you guys. All right, so 1.5 right here. And then we have to go down 1 and over 1. So if I went down 1, I would have to go to like the half mark, because that's a whole 1, and over 1 would be here and here. You see that? And then this one, very sad. There we go. Okay, now domain and range are going to be a little different this time. Not domain, of course. Domain's going to be the same, all real numbers. The range is a little different. This time, the range has a maximum value. Yeah, this is the highest that the y goes to. And then everything below it is on my graph. None of these y's above here are on there. So how could I represent that? Perfect. Y is less than or equal to 1.5. Were some of you thinking that before Jared said it? Yeah. Good. All right. Oh, it looks so pretty with all those colors. Now, the last two, we're going to do it all. We're going to find all these parts. I know, you like look at that and you're like, G, really? A through G. There's only one problem there. It's got 7 parts to it. Okay, so let's do it. First of all, let's go ahead and find the vertex. The vertex of this is going to be, if you want to think of it as a shift, you're starting at 0, 0, and you go 4 to the right and 2 down. So that would be +4, -2. Okay? So let's go over here. Let's go to +4, -2. There's my vertex. The axis of symmetry is going to be the vertical line that goes through the vertex. It goes through that point. So that would be the line x equals, what does x equal here? 4. And please don't just write 4. You have to write x equals 4. It's a vertical line. Okay? And then graph some extra points. So here we go. You can use any method you want. If you want to just count up 3, yeah.
Do we have to draw that like?
No, you don't. I was just showing it, yeah. So you can go up 3, 1, 2, 3, and over 1. And then you can think about the reflection over the axis of symmetry. You could also, if you wanted to, pick some extra points to plot. Like I could pick x equals 3 or x equals 2 and find out what the y value is. But I kind of like it when it's like a whole number like that, so that you can just count the rise of 3. Okay, now this graph has a minimum. Do you see how it has a minimum? The lowest number that it can be is right here. Everything else is above it. There's nothing below that. So they say that the minimum of the graph is the y value of the vertex. And so the minimum would be -2. It doesn't go past -2. And the cool thing about this is, if you notice, like the minimum is the y value of the vertex, and the axis of symmetry is the x value. So they kind of double up. Both of them do.
Do you have to put y equals -2?
No, you can just write -2, or yeah, you can write y equals -2. It doesn't matter. All right, domain, all reals, all real numbers for the domain. And the range, the minimum is going to help you with the range. If I tell you that the minimum is -2, then you know that the range has to be greater than or equal to -2, right? If you go to a PG-13 movie, the lowest age you can be is 13, right? So it's 13 or more. So this is the same thing. The minimum is -2. And then the Y-intercept. Okay, let's talk about the Y-intercept. The Y-intercept is going to be way up here. I can't see it on my graph. It's where this graph is going to eventually cross the Y-axis. And here's how you find the Y-intercept. You let x equal 0. Right? Think about the y-axis. Here's the y-axis. Every single point on this y-axis has something in common. They all have x equals 0. So if I plug in 0 into this, I get y equals 3, 0 minus 4 squared minus 2. Now your calculator can handle that. Did you know your calculator has parenthesis buttons? Yeah? Have you seen them? I'll show you. What am I plugging in? 3 parentheses 0 minus 4 parentheses squared minus 2. You could plug that whole thing in. You don't even have to think. It's crazy. Except yesterday on the PSAT when you had to not use a calculator. Yeah, you had to do some thinking. Yeah, you like that portion? Oh, we can't talk about it. I'll get fired. All right, 46. Yeah, I didn't. All right, 46. There you go. That's terrible. So the y-intercept is at 46. I would write it as 0, 46. That's going to be way up there. Would you like to plot that point? Here, I just did. Look at, there it is. Okay, sorry. Okay, one more and we're done. Yeah, tomorrow's is even shorter. I could have probably put them all together, taught it all today, but no, I don't want to overwhelm you. Okay, here we go, vertex. Let's do it, the whole thing again. This is a little bit different. It's going to be opening down. I can tell that because of that -2 right there. So the vertex on this one is, who can tell me what the vertex is? Ooh, a lot of you can. -3, +4. -3, 4. So go over to 1, 2, -3, 1, 2, 3, +4. There's our vertex. Plot that. Axis of symmetry, no, you don't have to draw it in. I kind of like to because, you know, I'm extra. But x equals -3. Is it bad to be extra? No. It's bad to be salty, right? Okay. Or tilted. I don't know what you kids say these days. It's adorable. Totes adorbs. You guys say that still? No. Salty. You're so crusty. Is that a good one? No? Crunchy? No? These are all, no? Nobody's crunchy? Yeah, people say that. All right. So -2.
20 years ago.
20 years. No one said that 20 years ago. All right. Down 2 and then over 1. Did you see how I went down this time? Because it's a -2. It's opening down. It's a very sad parabola. It's got a real sad face on it. Look at it. There we go. Very negative. Okay. So this time now, do you notice this word changed right here? Now it has a maximum. This parabola has a very top point that it reaches, and then it goes down from there. And that maximum is 4. It is. It's 4. And it's going to be that same number, like I said, in the vertex, that y value. Domain, all real numbers. Yep, just write it down and feel good that you got one right. And then the range this time is a little tricky. Yeah. Good. Y is less than or equal to 4. It's all the stuff 4 and below this time. Okay. Last one, let's find the y-intercept. You find the y-intercept by letting x equals 0 and plugging it in. So y equals, no matter what it is, if it's some crazy graph and you want to find the y-intercept, let x equal 0 every time. And this one's going to be pretty far down there too. Can you do that in your head? I hope so. Yeah? Yeah. Ooh, you can do it in your head? Good. This is 9 times -2 is -18 plus 4, -14. So that's way down there. I didn't do it. I did it right? PEMDAS. PEMDAS. Please excuse my dear Aunt Sally. So -2 times 0 plus 3, parentheses first, then exponents, then multiplication, and then addition. Wow, that has all of it, doesn't it? It had the whole PEMDAS in there, pretty much. Almost. -14. Okay, remember, please excuse my dear Aunt Sally? Yeah.